At 3:17 a.m., a dead lake flashes across radar. By sunrise, the basin looks empty again. So which picture failed first, the map or our intuition? Tonight, the driest places on Earth stop acting dry. Satellites keep catching ghost rivers nobody sees from roads. And the strangest part is how quickly they vanish. Most people imagine deserts as fixed, empty, finished landscapes. That picture is already too simple. From orbit, deserts behave more like sleeping circuitry. Take the Atacama in northern Chile. It is famous as one of Earth's driest regions. Some weather stations there once recorded years without rain. But satellites still caught dark branching streaks after rare storms. Those streaks were not shadows. They were rivers reusing channels buried under dust. That sounds backward, but desert ground can become almost water repellent. Long dry spells bake soil, build salt crusts, harden clay. Then sudden rain cannot sink in fast enough. It skates across the surface instead. A dead basin turns into temporary plumbing. That breaks the first map myth. The driest place is not always still. Sometimes it is where water hides worst. Sometimes a nearly waterless place moves water violently. Researchers see this in alluvial fans too. These are broad spreads of gravel below mountains. They look safe because they look old. During cloudbursts, they can activate suddenly. Many channels stay quiet for years. Then one storm picks a new route. That is why desert floods feel unfair. The ground looks stable right before it changes. The river may not be visible yesterday. Its path still exists in the slope. Water remembers downhill better than humans do. Now jump to the Sahara. From a car window, it looks endless and still. From orbit, parts of it look scratched with ancient drainage. Thousands of years ago, huge zones were wetter and greener. Monsoons reached farther north than today. Lakes, wetlands, and rivers occupied areas now called hyper-arid. You can still trace some of those old paths. Radar can penetrate dry sand under certain conditions. It reveals channels buried for centuries or longer. So a plain tan map misses water memory. The desert remembers where flow wants to return, and sometimes return happens brutally fast. A freak storm can dump months of rain at once. The water follows ancient low routes, like reopened roads. That is why flash floods hit places called bone dry. The surface is dry, the geometry is not. That myth matters. Dry does not mean safe from water. In fact, desert floods can be especially destructive. Plants are sparse, soil is sealed, slopes are bare. Water meets fewer obstacles. It surges hard, then disappears before most people arrive. In 2023, parts of Libya saw extreme flooding after rare rain. Dam failures and overloaded valleys amplified the disaster. A region known for dryness became a water corridor overnight. That contradiction is exactly what satellites keep exposing. The same reversal appears in smaller storms. A single thunderstorm can hit one basin, miss another. One valley stays dusty. The next one becomes a moving mirror. From ground level, that looks random. From orbit, it looks patterned. Tiny elevation differences matter. So do rock type, crust thickness, and vegetation cover. Two neighboring slopes can react completely differently. One absorbs enough to dull the runoff. The other sheds water instantly. The map color stays the same. Reality does not. Here is the weirder clue. Some desert lakes appear without local rain at all. The clouds can miss one place completely. Look at Australia's interior. It holds giant dry lake beds called salt pans. For much of the year, they look like white scars. Then a distant storm changes everything. Water can travel from rains hundreds of kilometers away. River systems slowly carry that pulse into closed basins. A lake forms where the sky stayed nearly clear. To someone standing there, the water seems impossible. To a satellite, the whole basin prepared for days. Lake Eyre, also called Katithanda, is the classic example. Most years, large areas stay dry. Then floodwater can spread across enormous flats. At full flood, the lake system can cover about 9,500 square kilometers. Birds arrive in huge numbers. Fish can appear where weeks earlier looked lifeless. That switch rewires entire food webs. Dormant eggs in the mud hatch. Brine shrimp and insects explode in number. Pelicans may travel huge distances to breed there. So the invisible river is not just water. It is a biological alarm clock. Even plants keep waiting for that signal. Desert seeds can sit dormant for years. Then one wet pulse triggers germination almost together. A plain brown surface turns green surprisingly fast. Flowers can bloom in sheets. Then heat erases the display again. Now move to the Arabian Peninsula. Sand seas seem to erase every sign of flow. But satellites repeatedly detect wadis. These valleys stay dry most of the time. During rare downpours, they become fast, dangerous streams. Many cities expanded near them anyway. Why? Because ancient people often settled where water occasionally gathered. Modern roads and neighborhoods later spread across those same routes. Then one intense storm revives the old pattern. A parking lot suddenly sits inside a river's memory. That phrase matters. Rivers have memory even when humans forget. Topography keeps records better than us. A dry channel can wait decades. One strange weather event is enough. Oman offers clear examples. Mountain storms can send water racing into otherwise dry plains. A wadi may look harmless by noon. By afternoon, it can cut roads. The flood may last briefly. The damage can last far longer. Now for the map problem itself. Official dryness maps usually summarize long-term averages. They are useful but blunt. They ask how much rain falls over years. Satellites ask a different question. Where did water actually move today? Those are not the same question. A place can have almost no annual rain, yet after one rare event, surface water spreads dramatically. A neat dryness category cannot capture that pulse. It freezes a process that is naturally jumpy. This is why experts use multiple measures: rainfall, evaporation, soil moisture, vegetation, groundwater, and runoff matter. One desert may get little rain but hold fog moisture. Another gets brief storms but loses water instantly. A third receives water from mountains far away. One label cannot tell the whole story. The Namib shows that perfectly. It is brutally dry by rainfall, yet fog from the Atlantic rolls inland often. Some beetles, spiders, and plants survive by harvesting that moisture. Myth says no rain means no supply. Truth says water can arrive sideways. Some desert beetles collect droplets using shell texture and posture. That is not a river, but it proves the same principle. Dry landscapes can receive water in hidden formats. The map says arid. Life here's opportunity. Chile's coastal deserts tell a similar story. Fog can feed specialized plants on certain slopes. These fog-fed communities survive where rain barely visits. The moisture is light but dependable enough, so one desert can be deadly dry below. A ridge above supports life from cloud touch. Deserts also hide cold surprises. Some high deserts receive snow, not just rain. Snowmelt can feed brief streams weeks later, so the water pulse may arrive delayed. The storm leaves, the runoff waits for warmth. That delay fools people on the ground. A dry day can still deliver floodwater. The rain happened upstream earlier, or snow melted after a temperature jump. A basin can flood under blue sky. That feels impossible until you map the whole system. Now the biggest twist. Space sometimes finds lakes before humans realize they exist. In recent years, satellite flood tracking improved sharply worldwide. Sensors combine visible light, infrared, and radar. Clouds can hide water from ordinary cameras. Radar often still catches the surface signal. That means a storm can create a lake at night. By morning, orbit may already log it. Why does the lake vanish so quickly? Usually, three forces work together. First, desert air can be extremely thirsty. Second, flat basins spread water into shallow sheets. Third, porous zones or fractures can pull flow underground. The result looks like magic. It is fast physics. In hot, dry conditions, evaporation can exceed 50 millimeters daily. That is not every desert every day, but it shows how fast shallow water shrinks. Spread a thin layer across a giant pan. Sun and wind do the rest. A blue patch becomes crust within days. Some basins leave bright mineral signatures. When water evaporates, salts stay behind. That is why certain dry lakes gleam white from space. The water is gone. Its chemistry remains as testimony. Those salts can preserve another clue. Repeated wetting and drying changes the surface texture. Researchers track these patterns over time. They compare storm years, drought years, and sediment fans. So the invisible river is not truly invisible. It keeps writing temporary notes across the desert floor. Sometimes those notes are geometric. Water outlines old shorelines and hidden levees. It darkens one strip, skips another. A basin can reveal its own topography in hours. After drying, the pattern fades. The next storm redraws it differently. Cracked mud tells part of the story too. When shallow lakes dry, shrinking clay fractures into polygons. Later, floods smooth some cracks and deepen others. These textures help scientists infer timing and depth. The lake disappears. Its fingerprints stay longer. The most dramatic examples often arrive during climate swings. Warm oceans can shift rain belts. Tropical systems may travel unusual paths. Atmospheric rivers can feed storms where few expect them. Deserts are not outside weather. They are hypersensitive to weird weather. Death Valley proved that recently. It is one of North America's driest places, yet extreme rainfall can turn salt flats reflective. Roads wash out. Fans and gullies activate. Visitors expecting emptiness meet moving water instead. In 2022, severe flooding damaged roads and trapped visitors there. The same basin famous for dryness became a flood headline. That does not cancel its aridity. It shows aridity and flash flooding can coexist. Low average rain does not prevent high-impact bursts. The same logic appears in the Sonoran and Mojave deserts. Monsoon storms can unload intense rain in short windows. Dry washes fill rapidly. One canyon remains dusty. The next one roars. The difference can be a cloud drifting several kilometers. Northwestern India offers another reversal. The Thar Desert is dry overall, yet monsoon variability can transform local conditions quickly. Ephemeral ponds appear and disappear. Pastoral movement, wildlife activity, and planting choices can change. A seasonal pulse rewrites the map temporarily. Even colder deserts do this. Parts of Central Asia look barren for long stretches. Then, spring melt or rare storms activate broad channels. Dry deltas briefly wake up. Dusty plains gain shallow water. The event may be short. Its ecological effect can be outsized. So when a map paints one huge region one color, it hides local drama. Slope, rock type, crust, vegetation, and old channels matter. A storm hitting baked clay behaves one way. A storm hitting sandier ground behaves another. one desert can contain many water personalities. That matters beyond trivia. Engineers plan roads, bridges, and drainage using this knowledge. Farmers watch temporary moisture for grazing and planting. Ecologists track sudden blooms after rare rain. Emergency teams need to know where ghost channels reactivate. A forgotten river can become tomorrow's hazard. Insurance models care too. So do mining operations and solar farms. Build across an old wash, and one storm can punish arrogance. A map built from averages may miss that. A map built from movement sees more. That difference can save money, habitat, and lives. But the strangest hidden water may sit under the sand. In some deserts, fossil groundwater survives from wetter ages. This is ancient water stored underground. People drill wells and uncover a hidden reserve. That can create green circles on satellite images. A brown desert suddenly grows irrigated fields. Saudi Arabia once used deep fossil aquifers for major farming. The circles looked almost futuristic from space, but much of that water was not renewing quickly. It behaved more like mining than harvesting. Again, the map saying dry was both right and incomplete. The surface was arid. The underground held an old inheritance. North Africa has similar surprises. The Nubian sandstone aquifer system spans several countries. It stores enormous groundwater accumulated over long timescales. That does not mean endless safe use. Ancient water can take far longer to replace than cities can pump. A desert can look empty and still hide a liquid archive. Groundwater can also reshape the surface. Where it reaches low points, springs may appear. Where it rises slowly, salts may collect. Where people pump heavily, the land can change. So hidden water is not passive. It leaves marks above ground. Now, the deeper reason official maps seem to break. Not all maps are failing. A simple idea is failing. The idea that dry places are static, empty, easy to label. They are not. They are event-driven landscapes. Think of deserts as systems of timing. Most days, almost nothing seems to happen. Then one pressure shift, one cyclone remnant, one distant downpour, and old channels, salts, seeds, insects, and birds all respond. Space sees those responses because space watches continuously. Humans usually notice only after roads disappear. There is another twist hidden in ordinary life. The same satellite logic now helps city planners. Why? Because many cities are spreading into drylands worldwide. The Ghost River problem is no longer remote. It is suburban. A dry lot near warehouses may have flooded before records began. A new highway may cross an old alluvial fan. A housing block may sit at a washmouth. Historical maps, elevation models, and radar reveal those risks together. So the lesson from remote deserts returns home. Invisible water paths still shape where people live. Even archaeology benefits. Ancient settlements often cluster near vanished water routes. Researchers use satellite data to hunt buried channels. Find the old water, and human traces often follow. Trade routes, fields, camps, and walls start making sense. A blank desert becomes a map full of decisions. That is why these discoveries feel so satisfying. They hide